Alright, so we're going to look at some chemical feed rate problems. And before we get into this specific question, I want to remind you guys that while we are preparing for, your exam, these sort of problems you actually are solving on a regular basis in the treatment facility. So a lot of the times operators are calculating this to understand how much chemicals they need to order to achieve the desired outcome. Over time as well, operators can, keep a log of the records of the chemical and the amount they're ordering, and they can kind of use that for budgeting and cost control. So it's a very common daily math problem that operators are using, and it's very important that you understand what's going on. And I know there are formulas to calculate chemical feed rate, but we're going to do a dimensional analysis to find the answer, because you might not always have a formula sheet in front of you. And I personally find that when you use dimensional analysis and just work through the problem step by step, it allows you to understand what's going on a bit better, and it also lets you catch mistakes as well. So let's read the question. It says, how many liters per day of 12% sodium hypochlorite solution are needed to disinfect a flow of 2,500 cubic meters if the dosage required is 8.5 milligrams per liter? A 12% solution of NaOCl weighs 1.19 kilograms per liter. Okay, so let's draw out what's going on. So we are flowing into some disinfection process. We're flowing in at 2,500 meter cubes per day into this disinfection process. And with the disinfection process, we are also dosing it with a solution of NaOCl, and we are specifically wanting to know how many liters per day of solution is needed. Okay, so that's what we're looking for. We're also told that it is a 8.5 milligrams per liter that we are dosing it with. So 8.5 milligrams of NaOCl per liter that we're dosing it in. Now I like to include these subscripts, okay? It just makes me understand what's going on a bit better. So it's telling me that the dosage is 8.5 milligrams per liter. It's also telling me that the NaOCl solution weighs 1.19 kilograms. So I'm going to write 1.19 kilograms of solution. That's how much it weighs. And then we're also told that the solution is 12% NaOCl. What does this 12% mean? Well, it means for every 100, I'm going to use you can use any mass as long as it's consistent with the numerator and denominator. So 12% solution means that, let's say, for every 100 kilograms of solution, 12 kilograms of it is NaOCl. In decimal form, that is simply 0.12. Again, I could have used 12 grams for every 100 gram solution. I could have used any mass unit in here, but I usually just opt to use kilograms. Okay, so this is what I'm given, and again, putting these subscripts, this NaOCl, the solution, it just allows you to understand what's going on a little bit better. So again, the question is asking me, how many liters per day of NaOCl solution do we need when we're flowing at 2,500 meter cubes per day? Now, the first thing, when I look at a problem like this, the first thing I want to know is, well, how many kilograms of sodium hypochlorite do we need per day? So let's figure that out. So how many NaOCl do we need when we're flowing at the solution? Well, we know that we're dosing it at 0.5 milligram of NaOCl per liter. We know that's our dosage, and we know that our flow rate is 2,500. We know that our flow rate is 2,500 meter cubes per day. That's our flow rate of flowing into our disinfection process. Now, we're gonna have to do some unit conversions here. The first being is that I want to convert liters over to meter cube. So just memorize this. For every 1,000 liter, we have 1 meter cube. And the next thing that I want to convert here is I have this milligrams, but I want to put my answer in a kilogram because I can already see this is going to be a massive answer. If you guys know, we're multiplying by 1,000 or multiplying by 2,500. It's going to be a big number. So I want to put it in kilograms. So I know that for every 10 to the 6 milligram, it is 1 kilogram. Okay, so looking at this, we are canceling our meter cubes here. We're canceling our liters, and we're canceling our milligram. Our answer is going to be in kilograms per day. And when I put these numbers into my calculator, I get an answer of 21.25 kilograms per day. Now, you can skip this part if you know how to do these conversions, but in case you just want a friendly reminder, how did I know that there was 10 to the 6 milligrams in 1 kilogram? Well, I use my King Henry died, mother didn't care much trick. And I know in the past we've used this for meters, but you can actually use this for mass as well. So meter, this becomes grams, this becomes milligram, this becomes kilogram. And again, it's the same trick. When you go up, you're dividing. When you come down, you're multiplying. And every step in this ladder means a factor of 10. So let's go from kilogram to milligram. So for every 1 kilogram, I'm going down to find milligram. So how many factors is that? That is 1, 2, 3, 4, 5, 6. And because I went down, that's going to be a multiplication. So that is going to be a 10 to the 6 milligram, or 1 million gram for every 1 kilogram. And that's how we had this conversion here. This one you should just memorize. It's used so often. It's good to just memorize. So how much NaOCl is required? Well, we need 21.25 kilograms per day of NaOCl. Now, we're not done just yet, because guess what? We don't have a 100% solution. We have a 12% solution. So we need to understand how much solution do we need to be dosing in when our solution is only 12%. We already know this is how much NaOCl is required, but we're going to have to do some dimensional analysis to understand how much solution we need. So again, I'm going to write, we know that we have 21.25 kilogram of NaOCl is required every day. We know that we have a 12% solution. Again, remember what that means? That means for every 100 kilogram of solution, only 12 kilogram of it is NaOCl. So I'm going to put this into my dimensional analysis that I'm doing, and I'm going to put the 12 kilograms at the bottom, just so that eventually we know we're going to have to cancel this out. So I'm going to put it at the bottom. I'm going to put my 100 kilogram of solution on top. Okay. Now what? Well, we know we're going to be looking for a liter per day answer. Okay, so keep that in mind. And when we look back at what we're given, we're also told that the weight of the NaOCl at 12% is 1.119 kilograms of solution for every liter. Okay, let's put that in. I'm going to put my 1.19 kilograms of solution at the bottom because it's going to help me cancel this top one out. And I'm going to put my 1 liter at the top. So what does that leave us with? Well, kilogram of NaOCl cancels out kilogram of NaOCl. Kilogram of solution cancels out kilogram of solution. And we're left with liters per day. And what were we looking for? We were looking for liters per day of solution as well. When we put this in our calculator, we get 148.8 liters per day of solution is required. And that is our final answer.